Let's practice with another one of these. We'll break out each vector into their x and y, and then sum those and find the resultant, and then we'll do the last extra step and find the equilibrant. So let's draw this one. 3. We have our x, which is also our adjacent, and we have our y, which is also our opposite. We're back in unit circle. So we have 0, 90, and those are positive, 180, and 270. We can see that this is 60 degrees. So our theta in this case is 60. We can find our x by cosine of theta equals adjacent over hypotenuse. And because it's pointing at 0, it's positive. 1.5 at 0 degree. At 0 degrees. And for the y, we'll do the sine of 30 equals opposite over hypotenuse. And we get 2.6, and because it's pointing towards 90, we have positive 2.6. And that's our first vector. If we look at the second one, we have 2 here, x there, and y here. Then we need to find our theta. We know that this angle is 135 degrees, and in our triangle, this is our theta. So if we do 180 minus 135, we get that theta is 45 degrees. That means this is a special triangle. That means that the x side and the y side are equal to each other. You can calculate it twice, or you can just calculate it once and put it for both answers. So cosine of 45 equals x and y over 2. It's okay to not do this twice. You should know that in a 45-degree triangle, the sides are the same. So our x is pointing at 180, so it would be negative 1.4 at 180 degrees. And our y is pointing upwards, so it would be positive 1.4 at 90 degrees. And then we could sum them. For x, we'd have positive 1.5 plus negative 1.4 gives us a very, very small positive 0.1. Because it's positive, that means it's at 0 degrees. For y, we have positive 2.6 plus positive 1.4 gives us 4.0, and because it's positive, we know it's at 90. So, particularly in comparison with our x, that y is very, very large. So when we draw these, and if I tried to draw them realistically, it would be illegible. So, my x is pointing at 0, and my y is pointing at 90. My resultant is right here. And we should be able to tell that our theta is going to be very close to 90 degrees. So we have 4 squared. And we get this d squared is equal to 4.001. So we are going to say that C is equal to 4.0, even though that looks just like our y side, because unless we keep an extreme amount of digits, they're not any different. And that's okay. Now to find our theta, we have tangent of theta equals opposite over adjacent. And we have theta equals 89 degrees. And we said it was going to be very close to 90 because the x's in these two vectors cancel each other out. And you can see that that's the case. Now when we double check our unit circle, we see that our theta is in unit circle already, 89 degrees. And for our equilibrant, we would add 180 degrees to get our final direction for our equilibrant of 269 degrees. So our final answer is 4.0, or if it really bothers you, you can have 4.001 so that you can see that they're different, at 269 degrees.